Welcome to the AP Physics lecture. This is on Unit 2, Dynamics. This is going to be your intro to pulleys. We'll start off with looking at what a pulley is. A pulley, what a pulley does is actually changes the direction of a force. Normally we see our force as just up, down, left, and right. The interesting part is that now, if we put that force here on this block, notice that the force going up and there is a force going down. The down direction here can be considered positive. Notice that if you follow this arrow as it goes up and around the pulley, it now wraps around the pulley, goes to the other block. So notice going up, this block is negative. Wraps around, as it comes down here, it's going to be negative. So that negative direction was wrapped around that pulley. That's what it means to change the direction of that force. This occurs when the magnitude of so what does not change is the magnitude of the force. So if it was 5 newtons, it stays 5 newtons. The only thing changed is its sign. There are two criteria for it. This is when the pulley is massless and frictionless. And 2, when the string is massless and also inelastic. This scenario of a pulley, when you have 2 hanging masses, is called an Atwood machine. An Atwood machine is a pulley system consisting of mass connected by a string that are hanging, that is experiencing the pull of gravity, AY equals to G, which is equal to 10 meters per second squared. So if you look at this example, the 2 blocks here are experiencing the gravitational pull vertically at 10 meters per second squared. A couple of notes. 1, if these 2 masses are the same, like mass is equal to 5 kilograms here and mass is equal to 5 kilograms here, that they're going to be essentially balanced because it's in equilibrium. The system will always accelerate towards the side that has the greater mass. Notice in this, I increase the red block, and notice it now accelerates down on that red side. It accelerates down because that side has more mass. It is always convention to always take the side that's going down as the positive direction. So here the red mass is going down, so I consider that to be the positive direction. And the blue mass, which is going up, I would consider that to be the negative direction. So right here, you would say that the system is undergoing a positive acceleration here. There you go. And again, it's accelerating down the side that the mass is largest. So to help you along, we have this problem here. The pulley. This is an Atwood machine and it has 2 hanging masses. M1, which is equal to 5 kilograms, and M2, which is equal to 10 kilograms. The question asks you to find the acceleration of the system once the system is released from rest. So the approach is the same. Let's look at the 3 questions. First, the question is asking for the acceleration, so your A is equal to your question mark. It's in the vertical axis, and if you set up the summation, it is the summation of Y is equal to M cis and A. M cis just stands for the mass of the system, because again, this object is moving in the vertical direction. Here's the diagram. There is a force going down, which is the force of gravity on the second block. And there is a force going down here that is also on the force of gravity on block 1 as well. So there are 2 forces here. These are your external forces. Yes, there are internal forces here. There is an Ft going up and an Ft going up here. But these 2 are your internal forces. They basically cancel each other out, so we don't draw them. So if you look at the diagram, these are your 2 forces here. Force of gravity on block 2 and force of gravity on block 1. Now we're going to do the sum of the forces. So again, this is the summation of the forces in the y direction. Your 2 forces here is force of gravity on block 2 minus the force of gravity on block 1. I make one of them positive. And again, like we said from before, I make the positive direction based on the mass that's going to fall. Now we can solve. I make that substitute in, so it's mass of the system times the acceleration is equal to the force of gravity on the second block minus the force of gravity on the first block. Force of gravity on the second block is just m2g. Force of gravity on the first block, it is just m1g. I can divide mass this to either side, so I can get acceleration alone. Now I can see that on the top of the fraction, the g is the like term, so I can just factor it out. That's what acceleration should look like now. I make the substitution in here for all the variables, and I get acceleration is equal to 3.33 meters per second squared. That is the acceleration of the system. And again, it's falling on the m2 side because that is the largest mass. This is the same question now, but it asks what is the speed of the falling block after 2 seconds from release. Well, here, the question mark is going to be your velocity. But how do we solve for velocity? The speed. Well, we know that you have the acceleration, which is around 3.27, or from the last problem, I think we used 3.33 from the previous step. You know that time is equal to 2, and velocity naught is equal to 0. This should remind you to use a kinematics equation because this object is just undergoing free fall. So it's a kinematics equation. So I'm going to use the classic kinematics. V equals to AT plus V naught. That is your linear equation for it. Make the substitute in here. Again, if you use 3.27 or you can use 3.33. Okay, it depends if you use 10 for acceleration or 9.8. Then you should get the answer roughly around 6.54, or I think if you use 3.33 times 2, it would be 6.66, or it can be 6.66 here. All right, that would be how you find the velocity. Okay, make sure you understand that you have to use the kinematics equation to solve for the velocity. Now, the last thing is that this is the same scenario as before, but the mass changed. But also, there's a motion detector here. First of all, it says here, this Atwood machine is set up by suspending 2 blocks connected by a string of negligible mass over a pulley, as shown here. The pulley has these mass, and there is friction between the rotors. So this pulley here, there's going to be friction. Okay. When the system is released from rest, after 1 second, the speed of the block is 3 kilograms. The speed of the 3 kilogram block is 1.8 meters per second. Which of the following is the best estimate for the external friction force acting on the 2 block system? So now that the fact that friction is involved, you want to actually compute that friction. Don't freak out. The way you solve this is the same exact way. Okay. So here's the part. You want to make sure you want to find the acceleration first. It's in the vertical axis. And then we saw that it is moving in the vertical direction. So it's the same setup as before. Same diagram. Okay, force of gravity on the second one. I'm going to make that negative FG1. And on the first one, I'm going to make that FG2. Again, it's going to fall on the 3 kilogram side. That's why I made that positive. Same forces here, but remember the FG2 is going to be positive and the FG1 here is going to be negative. Right? Then you should see how I got to this step. It's the same way as before, so I'm not going to show all the steps. Okay? Then once you plug it in, you should get 2 meters per second squared, like the last problem that we did. Once you solve for this acceleration, you now need to understand what happens to this. This is the acceleration without friction. So if the pulley here was frictionless, it should be accelerating at 2 meters per second squared. But the problem said that the acceleration was really 1.8 meters per second. So this is the acceleration when there is friction. And this is without friction. What is the difference between this? The difference is 0.2 meters per second squared. This is the acceleration due to friction. So just think about this as a subtraction problem. Okay, this is your real amount without friction. This is with it is friction. So the difference here is going to be the acceleration due to friction. Once you have the acceleration due to friction, you can plug it into the friction formula to find out the force. So the mass was not, the mass should not, the mass is blah blah, which of the following is the best okay, it's acting on the 2 block system. So please understand that this is the mass of the system. This is the 3 plus 2. And this is the acceleration of the system, which is 0.2. It's going to be 5 times 0.2, which gets you 1 Newton. So during this whole experiment, the fact that the friction force here causes it to lose acceleration, it loses 0.2. If you plug that into the force equation, it becomes 1 Newton. So the external force of friction acting on the system would be 1 Newton. All right. So there you go. This is your introduction to pulleys. Hopefully this gives you an understanding of what the pulley does in terms of changing its direction, understanding a problem with the pulley, understanding how you can get velocity from the pulley, and seeing how friction impacts the pulley's acceleration. There you go.